All right, gentlemen, let's take a look at this. Our learning goal for 3.1 is to understand that a median bisects the area of a triangle, and to understand that a centroid is where the medians meet in a triangle, and the circumcenter is where the right bisectors meet. Circumcenter also shows us that the circumcenter shows us a point that is the center of a circle whose circumference goes through all 3 points of a triangle, all 3 vertices of that triangle. I'll explain what I mean as we get to the circumcenter question. Let's take first a look at the centroid of this triangle. So in order to draw the medians, we only need to draw 2 medians. Automatically, the third median will have the same POI as 2 medians. I'll say that again. So when we're drawing the medians of this triangle to find the centroid, as long as we can find where 2 medians intersect, the third median will also intersect at that point. So we don't really need to prove that. That's a proven fact already, that the medians meet at the centroid. So to save yourself time, only find the equation of 2 medians and their POI. How can we sketch that? Well, if I want to sketch a median from vertex B, for example, then what I'll do is I'll take a look at the median. I want to find the midpoint of AC, because the median goes from a vertex to the middle of the opposite side, or the midpoint. Well, I'm going to do this by observation a little bit. I know that from A to C, it goes up 6 and right 1. So the middle is going to be up 3 and over a half, which is the halfway point, right? Half of 6 is 3, and half of 1 is 1/2. So I'm just going to do that for the sake of the video here. And then I'm going to grab my ruler, and I want to draw a line from B to that midpoint. Let me just try and line that up. Okay. And a median is within the triangle, so I stop right there. And we've drawn 1 median. To label that properly, of course, we're going to put the hash marks here. And there's our first median. If we want to find a median, let's say from vertex C, then I'm going to need to find the midpoint of AB. So the midpoint of AB, I'm looking from A to B. My line goes over 8 and up 1. So in this case, I need to go up over 4 and then come up to the line. So up a half. So there's my midpoint. I'm going to put my hash marks right now to show that. And then let's get our ruler, and we will draw a line from C to that line, that midpoint, right? And now we have our centroid. Okay, so our centroid is that point right there. Okay. If we wanted to do this with analytic geometry, there are many steps. So I want you to take a moment to see if you can outline the steps it would take to find the centroid using analytic geometry. And then you can compare your answer, maybe pause the video and take a look. So I'll try that here. The first thing I'm going to want to do, if I'm finding the centroid algebraically, I'm going to find the midpoint. We said we found the midpoint for the first median of AC, line AC. That was the first thing we did. The second thing we did was to find, we're going to have to find the equation of that line. So let's take a look at the steps. In order to find the point of intersection, I need to first find the equation of what I just highlighted in yellow. Then I need to find the equation of what I'm highlighting in green. And then we're going to have to find the point of intersection between those 2 points, or the 2 lines. So in order to find the equation of the yellow line, I'm going to find the midpoint of AC. Then I'm going to find the slope. Let me call the midpoint of AC, let's call that E, and we'll call this green one here D, so D and E. So we're going to find the midpoint of AC, and then I'm going to find the slope of line BE. Okay. Then number 3, I'm going to find the equation of BE, line segment BE. So using the midpoint and using the slope, I could sub in the midpoint, solve for B, and find the equation of BE. That's my equation number 1. That's equation 1. And then the fourth thing I'm going to want to do is find the midpoint of AB, because that's that coordinate D. This was midpoint of AC, we called it E. Midpoint of AB, we're going to call that D. Then I'm going to find the slope of CD. And then I'm going to find the equation of CD, line segment CD. That's my second equation. And then the final step we'd have to do, I know it sounds like a lot of work because it is, is we're going to have to find the point of intersection of 1 and 2. 1 and 2. Okay, and that'll give us our centroid. Let's take a look at now circumcenter. We're finding the circumcenter, we're finding the point where the right bisectors meet. Okay, so if I'm going to find a right bisector, let's kind of do what we did with the last question. That helps us out a little bit. I already know it's the same drawing, so my midpoint was here, and the other midpoint was there. I'll put my hash marks. Okay, but this time I need to use the right bisectors. I'm not using a median. So this has to be at a right angle or 90-degree angle right here. That's 1, right through the triangle. Okay, so here we go right through. I draw my right angle, great. And now to find the next one, I'm going to get my ruler again, and we're going to go, again, right through at a 90-degree angle. Let's see if I can use my ruler to kind of create a 90 there. It looks like a 90. And I draw that straight through. And I'll draw my 90-degree angle. And so you'll notice that a right bisector doesn't necessarily go through a vertex, okay? And so we have to just make sure you're drawing at a 90-degree angle. If you're sketching that, you can use your ruler and line it up, and the corner of the ruler will make a 90-degree angle with the line, and that'll help you find that. All right. Now, I mentioned earlier in the video that the circumcenter is also the point, the center of a circle whose circumference goes through all 3 vertices of a triangle. So I'm going to try and use my technology to do that. If I can, it's going to go through all 3 vertices of that triangle. That in itself wasn't that bad, but something like that. I might be able to expand that a smidgen just to cut right through point C. Close enough for now. All right, so that is the center of a circle whose circumference goes through all 3 vertices of a triangle. That's what the circumcenter is, but it's also where the right bisectors meet. That's how to find it. And just like the centroid, the third bisector, right bisector, will also meet at the circumcenter. So we only have to show 2 right bisectors meeting in order to find the circumcenter. And now you might want to pause the video and outline your plan. How would you use analytic geometry to find the circumcenter? Here we go. The first thing we're going to do, oh, we're still in ink to shape, so let me get rid of that. All right, first thing I'm going to do is find the midpoint of, we're going to call that, we said we call that D and call that E. Let me label that properly. So I'm going to find the midpoint of, let's say, AB. And then I'm going to find the slope of line AB. And that point was equal to D. Slope of AB, but then I need the negative reciprocal slope because this bisector here is perpendicular to AB. And we're going to need to use the negative reciprocal slope and point D to find the equation of line, let me call it, I want to call it the bisector, equation of bisector through D. And that's going to be equation 1. Then we're going to do number 4, we're going to find the midpoint of AC. We're going to call that E. Then we're going to find the slope of AC and take its negative reciprocal slope, because that's what we need. And then we're going to have the equation, or find the equation of the bisector through point E. Clean that up. And the final thing you're going to do here is find, and that would be equation number 2. And then we're going to find the POI of equation 1 and equation 2, and that will give you the circumcenter. Okay, take a moment to review that, and I'll take you through these questions quickly. This may be a bit of a review from grade 9. The real key here is if you look at the learning goals, that to understand a median bisects the area of a triangle. A median bisects the area of a triangle. So in this case, how do I know this is that this line from A to D is a median? Well, I've got the hash marks here to prove it. So that means D is indeed the center of line BC. So AD, the line AD in green there, is a median. So if the area of ABC, which is the entire triangle, if the area of the entire triangle is 22 square units, what is the area of triangle ABD, which would just be the one I'm outlining in red here? Well, then the area of triangle ABD is equal to 22 cut in half. So 11 square units. Okay. And then likewise, if the area of EFH, just the shaded triangle, if the area of that is 36 square units, then what is the area of EFG, which is the entire triangle that I'll outline in red here? So the area of triangle EFG, notice they're writing it in alphabetical order, is equal to 36 square units, but times 2. So which is 72 square units. Something else that comes up in the homework, and I'll just help you with the math language here, is which of the following, A, B, C, and D, coincide in triangle PQR, given that PQ, and it's got that little symbol there, the equal sign with a little squiggle over it. That means congruent, or exactly the same size and shape. So PR is congruent to QR. That means that those two side lengths are equal. Therefore, we have an isosceles triangle. Okay, so now we have an isosceles triangle. Let's take a look at what it's saying. Coincide, by the way, coincide means which of these exists and is true at the same time. It asks us if the perpendicular bisector of side PQ, well, the perpendicular bisector of side PQ would be a line that goes to the middle right through there. But because it's an isosceles triangle, that bisector, right angle, I'll do a hash mark here and a hash mark there. I'll make that a double because we want to differentiate between the two equal sides of the isosceles. If I look at that median, that are from R, let's call this S. The line from R to S is a median because it goes to the midpoint, but it's also at the same time simultaneously a right bisector because it's an isosceles triangle. Well, right bisector in an isosceles triangle, that cuts that angle. I'll call that angle A, and let's call that angle A. Those two angles are equal. Okay, oh, my A just disappeared. Those two angles there are equal. So a median in an isosceles triangle, that right bisector or median, same thing in this case, also bisects the angle. So that is a bisector of angle R. That is true. So far, the perpendicular bisector of side PQ, okay, and the altitude from side PQ, that's also an altitude, and it's also a median. So it's a median, it's a bisector, and it's an altitude of, and it's also the bisector of line PQ. They all coincide. All right, I hope that helps. A little bit lengthy, I know, but what's really important here is you understanding the steps to outline how to find the centroid, how to find the circumcenter, which one means where the medians meet, which one means where the right bisectors meet. Okay, talk soon, see you in class.